I'm going to try and draw a link between BIM and building performance. I'd like to just give a brief introduction of who we are and what we do for those of you who don't know. And then I'll talk a bit about the context of building performance, how BIM and soft landings can be beneficial in improving building performance, and then just cover very briefly a couple of case studies to try and illustrate the benefits. So we are a UK-based company headquartered in Glasgow with offices around the world, and we specialise in building performance analysis software. Okay, so energy modelling, dynamic simulation, daylighting, those sort of things. Our mission statement is really that any building anywhere in the world can be designed and operated optimally or to the best of its ability using our technology. So just to set a bit of context around this, why is it important even? Recently, COP21, the agreement in Paris, saw a strengthening of the global response to the threat of climate change by holding the increase in global temperature to well below 2 degrees above pre-industrial levels. Against a backdrop of an estimated construction boom culminating in up to $15 trillion output by 2025 as a result of rapid population growth and urbanisation. So that's quite a tough challenge to achieve the COP21, what it's setting out to do with the level of construction that's anticipated as well. In the UK, buildings are accountable for around 37% of total carbon emissions. And we need to see quite a shift in the energy efficiency to achieve the 2050 target. So 80% reduction in greenhouse gas emissions by 2050, 50% reduction by 2025 is what the UK government is currently targeting. Across the entire building stock, we see quite a dramatic discrepancy between predicted energy consumption and actual energy consumption. So the green bar is the BER, which is what we predict using a compliance approach, Part L EPCs, and the red bars are obviously how that sector performs in reality, the actual energy consumption or emissions. And this is what we term the performance gap. So the gap between, the difference between expected performance and realised performance. CIBSE TM54 goes into quite a lot of detail and provides a methodology to better predict energy at the design stage. If you look at the bar chart, you can see the part L is the smallest bar on the left, so that's your compliance calculation. If we apply the TM54 methodology, which looks at things that are not included in the compliance calculation, such as out of hours, use of the building, special functions, plug loads, unregulated energy end uses, you can see there's quite a difference. So Part L in compliance is fine for what it's aimed at, what it's designed to do, which is basically benchmarking different buildings against one another, comparing the building performance of a particular sector. Whereas when we're looking to improve energy performance, building performance, we need to consider all of the energy end uses, okay? And we need to look at the real picture of how the building will be operated. Carbon buzz just reiterates the point. So Part L in EPCs covers regulated energy end uses. Beyond that though, we need more information, better energy prediction during design, in order to try and close the gap. So we need sight of how the building is potentially going to be used realistically. So BIM and soft landings provides a mechanism, a vehicle to do that. With a BIM-enabled approach, we have, in theory, more information and better quality information available to designers on which to base their decisions, which in itself can result in better performance. We also have the requirements set at the beginning, so at the outset of the project. What is important in this project? In soft landings, which covers not just energy, so any aspect of performance. I mean, it could be visual comfort, thermal comfort. It can be obviously carbon cost, value, whatever's important to the client in the ongoing operation of that facility, okay? And the fact that it gives us the up to 3 year post-completion handover, or even further ahead than that if the client is engaged and interested in looking at feedback loops and performance, so energy feedback loops, availability criteria, things like that. And it means that if something isn't working properly or the building use has changed post-handover, those sort of things can be captured and looked at and understood because they have an impact on the energy consumption. So within IES we talk about 4 different types of model. We have the design model, which equates to the TM54 example, so the real building example. We have the compliance model, which is a separate exercise, a theoretical study of how the building will perform under a prescribed set of criteria. We have the operational model, which once the building is operational, up and running, we can develop the design model into operation by visiting site, by conducting structured interviews with the building users, as set out within the TM54 document. So we can more accurately match the operation with the energy model. And then we have something called enhanced operational model as well, which enables us to bring real-time data from the building or any building into the design, so we can inform subsequent designs, or we can just we can use it for commissioning, and we can look at diagnose any problems within the building. So one of the things that we do a lot with that is just looking at base loads. So, when the building's unoccupied, what is the base load and why is it consuming as much energy, producing as much carbon as it is? The first case study that I'm going to look at briefly gives an example of this idea of using operational data from a building to better design the next building. This idea of an enhanced operational model. So it's a customer case study, so we do try and encourage customers to bring out their success stories as much as possible, so that it's not just IES banging the drum and saying the same things over and over. It's design of a new John Lewis store in York. The company is Lateral Technologies. They were tasked with developing the lowest energy John Lewis store to date. They use our software extensively. They're a commissioning firm moving into design, so they see the value in connecting design with operation. We were employed, or we worked alongside them to develop a more sophisticated monitoring solution, which enables the overlaying of the real-time data on top of the design data. And as I say, we use that to support commissioning efforts, for measurement and verification, and ultimately for the soft landing side of things. So we can gather data, we can look at it, and we can decide, why is the building performing this way, or could it be better? Okay, so the target for the new store was a 30% reduction on a similar existing store in Exeter. With the Exeter store, the existing store, it's gas and electricity that you can see there, heating and gas and electricity. With the new store, they actually sort of prescribed what the energy targets were for each of the different energy end uses. We were involved in terms of mapping virtual data points to real data points within the building. So examples there, the cafe CO2, where does that exist within the model, and tying those two things together. So from here, we were able to look at the chiller operation, chiller performance under different conditions, and then we could sort of predict annually what the chiller performance would be. So we could look forward based on the real operational data feedback that we were getting. And the same for the fan coil units. So this is real data. Once the building's up and running, are the fan coil units performing as we would expect them to, as we would want them to? And could they be tweaked at all? The end result was that just by using the operational data from the Exeter store in terms of when the lights are on and off, things like that, in the design of the new store, they were able to right-size the equipment, so the chiller capacity was reduced by 25%, which provided obviously an capex saving. And by tightening up the controls through the commission period, they achieved over a 40% improvement on the original store. Subsequently, the building has been awarded BREEAM Outstanding for retail, and it won the Collaborative Working category at the recent CIBSE Performance Awards. And none of that is much of a departure from what engineers, consultants are already doing. So it's just a case of getting hold of the data and actually using it. The second case study is one by HLM Architects. So this focuses on a new residential development in Chelsea, which is currently going through the sort of second round of planning. The target here, as some people I guess will know, is the GLA requiring a further 35% improvement in carbon emissions against the Part L 2013. So that's quite a tall order. For residential buildings, that is. So they pursued an integrated design approach. This is not one that we were involved in, but we are at liberty to present it. An integrated design strategy focusing on passive measures, so good daylighting, good use of solar energy, incorporation of the winter gardens within the design as well. And just a joined up solution, more detail going into the building model and the systems modelling from the outset. This might be more in line with other people in the audience's experience thus far with integrating analysis within your BIM process. So HLM Architects use Graphisoft ArchiCAD as the BIM platform, and they were able to link that with the analysis model, and also then feedback results from the analysis back into the BIM platform. So this round tripping of data. In this case, we're looking at some of the plant loads being pushed back into ArchiCAD. So iteration through the design process with the BIM model enabled optioneering, refining the systems to give the best results, and a much better result obviously than using more simplified methods such as SAP for compliance. Obviously again, with the difference in results, you can see the potential saving in OPEX from energy reduction. But the interesting point with this project as well is that it's kind of moving the industry forward. The dialogue has taken place with GLA. They've in principle accepted the more detailed simulation results, although we still have to produce SAP certificates for submission. But just being able to try and to move the industry forward, I say, for BRA to recognise alternative routes to compliance and GLA. So hopefully this has given some insight into the benefits of BIM and soft landings and improving building performance during design and post handover. So just basically CapEx and OPEX savings that can be achieved. Information obviously is the link between the two. There's a lot of information out there. Not all of it is particularly well used, especially if we're just going for compliance. We need to kind of move beyond looking at compliance as the end goal. We can build in learnings and maintain the continuity of data throughout the process. So this idea of soft landings is a golden thread of information from design right through to operation. Sharing, I think, one of the kind of obvious things for us, and I think it's kind of come up, some of the case studies that we've seen today and yesterday, sharing information, obviously being fundamental, but sharing experiences, I think, as well. So I think it's important to get success stories out there to inspire others within the industry to embrace the change. There are some really good case studies going around. And thus moving us forward to the digital future that the government envisions in digital built Britain and beyond. That's me. I'm done. Thanks very much.
Sarah, thank you very much indeed.